So in the previous session, we have seen that how we can make our data private. But if we still want to access, we can easily access, right? Which made me more depressed that why we can't do that. Because in the other languages like Java and C, C++, we can do that, right? We can make our data fully private and nobody can access no matter what happens. But in Python, we can access. So while researching, I found one single line on Stack Overflow and which made me smile. And I'm sure that when you listen this, you will also smile, which says Python is made for adults. Python is made for 18 plus. That's why nothing is truly private in Python. Because as we have seen previously that Python is so flexible that it doesn't restrict you completely for anything. You have the option to make your data private, but if someone from your company is still trying to access that, then that is the problem of your company culture, not Python's, right? That's why we have the option, but we also have the flexibility to access in case if sometime it is required. So that was one liner. Now let's move to the next topic, which is getter and setter method. So let me share my screen. So when we make our data private, Python automatically converts that to a different name. So here you can see it was underscore class name, then double underscore, and then attribute name. But even after that, you can access the attribute, but you cannot make changes to the private variable. So that was the explanation. Now let's understand one more thing. To understand the getter and setter method. So let me open the terminal. You can see here we have made all these attributes as private, and I cannot access with just let me run this, and at here the name is bot3 dot. If I write threshold, then it says if I write like the class name, so auto trading bot, so auto, when I hit shift enter, we get the value, and with the help of this we can even change the value. Let's see if I make it 70,000, so the value will be changed, and when I again access this, it will show me a modified threshold. We can say that we have the flexibility, but we have the drawback also, right? So in order to resolve this issue, we can use getter and setter method. So let me quickly first explain you what are the getter and setter methods. So let's start the example of getter and setter method. So what we will do here, we'll just take this code and paste it here. Okay. So when I hit shift enter and I try to access the data from here. So let's say I'll create another object with the name bot4, and I'll give the class name with the threshold value. So let's say it's 70K. And now when I add another cell here and try to access the attributes from inside, I can see that position, price data, and threshold is still visible. But if I try to access done already, I'll add the class name here. So auto trading bot and hit enter, and it will return me the threshold value. And we don't want to give the direct access to the data to any other person. So what we will do here, we'll use another method, that is getter method. So what I'll do, I'll just write here, define get, I'll give here any name. So let's say what it will do, it will just return the threshold value, right? So it will return the return and self dot, yeah. So now I hit shift enter, and so now when I try to access this, I'll write bot4 dot, and now when I try to access this, so what I'll write bot4 dot, and here in the suggestions you can see we have another method which is get attribute, and I'll select this, close the parenthesis, and now actually we don't want this for now, so I'll just remove this. So I'll just remove, and I'll again shift enter, and now when I run this, we can see that it is returning us the value of the threshold. So with the help of this getter method, we can easily avoid giving the access to our data. We can give a method, with the help of that method they can access the data and they can use it. So now let's say I want to change the value of this, I want to modify. So what I'll do, I'll set another method here, and we can name it as set attribute, and here self, and we can say modified threshold, so or new threshold. So here what it will do, it will just it will return the self dot this one. So now let's try to access this. So I'll just hit shift enter, and here I'll take another cell and I'll write bot 4 dot. So here we can see the set attribute also. So here I will change the value from 7,000 to 8,000 or 80. When I hit shift enter, it is returning us the 80,000. And if I check here now, it has changed to 80K, right? This is how you can use the getter and setter method. And this is the safest way to give the access of your private data. If the person wanted, what he could have done, he would have just changed this to string. And when we hit shift enter, and when we try to access this, and after that, if I have more functionalities like the execution or the comparison, then definitely it will not be able to do that because this is a string. So in order to avoid that, what you can do, we can add a conditional statement here. So if new threshold, so the type of new threshold is equal to str, then it will perform this action. Otherwise, if we try to be over smart, what it will return, don't try to be over smart, right? And now when we hit shift enter, it says expected. Yes, it expected here. So now when we try to access this, so I'll just hit shift enter and it still returns me the string. So what we can do, I'll just change it to a string, of course. And now when I try to change, so now let's say if the junior programmer wants to make it a string, so what it will be written, don't try to be over smart. And if you're working fine, let's say giving the right value, it will work fine. When we give the right value here, so let's say 8,000, we have to change it to int. If the junior programmer now give any other value than integer, it will be displayed as don't try to be over smart. Let's say if he is giving correct value 8,000, then it will be working fine. So this is the example of get attribute and set attribute, and it will be very useful for you to make your code more safe. Now we have collection of objects. So in this, what we can do, let me take this example again, trading bot, or I'll paste it here. And here what I'll do, I'll just change these values. Let's say it was the threshold, and we can also give the name like the stock name. So let's say stock name, and here stock name, let's say stock name, and I'll remove this one. Okay, so we have two parameters. The first is stock name and second is threshold. I'll hit shift enter, and then if I try to create object of this class, so what I'll do, I'll create here. So let's say I'll create capital bot 1 is equals to auto trading bot, and here we will provide two values. The first is the stock name. So let's say I'll give Apple, and threshold we can provide is, let's say 110. We can also have bot 2, which is again equals to auto trading bot, and here we can provide, let's say Microsoft, we can give 150, correct? And let's take two more value. So I'll just copy and paste this again, and I'll quickly change here bot 3, bot 4, and Apple to BTC, and Microsoft to Ethereum. So now what we are doing here, we have created 4 objects, right? So when I hit shift enter, so now as we have seen already so many times that in Python, all the data types like integer, string, and this class, functions, all are objects, right? So I'll add these inside the list. So bot 1, then bot 2, and bot 3, and bot 4. And if you can imagine, this is very powerful. Now we can treat the class objects as a normal data type, right? List on these, we can perform dictionary, we can perform any operations which we can do on other data types. So let's say bot1, and if I want to apply for loop, so for I in L, print I, and when I hit shift enter, all the objects will be printed out. This is really powerful, right? Now if I want to access these values, what we can do, we can give the class name, then the attribute name. But let's just, for the sake of simplicity, what we'll do, we'll just make it a normal attribute for now. But make sure you make a habit that whenever you are creating the class, and inside that you make all the data private, always a stroke name or threshold name. So what I'll do here, I'll just give I dot threshold, and now when I hit shift enter, all the threshold is printed out. And if I want, I can also print I dot stroke name, right? And with this, you can imagine the possibility you can perform with Python. Means there is no limit, sky is the limit. You can do whatever you want with the Python. Just your basics need to be very strong. If your fundamentals are strong, then you are the unstoppable. Then again, if we can make list, then of course we can make dictionary also, right? So what we can do here, let's say we have this, I'll go here and I'll type D, and here what I can do, instead of this, I'll change to the curly braces, correct? And here I'll give like P1 and P2, P3 and P4, correct? It says P1 is not defined. Actually, we have to make this a string. So P1 and P2, P3 and P4. So now when I hit shift enter, we can use the for loop. So for I in D and print. So if I want to print the values from the dictionary, what we can do, we can write like the stock name. So when I hit shift enter, it will print all these stock names. And if I want the threshold, so you can do that also, shift enter, and all the threshold will be printed out. So now we are able to like the normal data type, and we can perform all the operations, right? So now we have again one very important concept, which is static variable. So as we have seen that all these are instance variables, because see, and this self.stock name is also an instant variable, because whenever we create the object, it gets executed and we can get the value. But what if I want some variables, for example, in a trading strategy or in a trading application, we want to count the trade number, like we have a trade ID. If I want to apply that counter, that how many trades are being happen here. So whenever we make an object of this, so let's say I'll create a counter here. So self counter plus equals to, and here I'll give the value, the initial value. So we can give it as self dot, or in the starting we can give it. So now let's say we want to apply a counter to this class. So like in a trading exchange, whenever a trade happens, we should be able to count that, right? It should be assigned a trading number. We want to apply a counter. So I'll write here self dot counter is equals to 0. So whenever an object is created, this counter gets incremented by 1. So self dot counter plus equals to 1, correct? I dot counter, right? So when I hit shift enter, you can see that we are getting the value 1 for objects, which we don't want. We want to increment it one by one in each trade, right? For that, we need a static variable, because this instance variable will always given a 0 value each time an object is created. So what we can do, we can give a static variable, and for that we have to define this outside of the class. So here I have to write this counter equals to 0. Whenever an attribute is outside of the function, that variable belongs to the class. If I want to access that, I have to write the class name auto trading bot and counter plus equals to 1, correct? So now if I want to access, so I'll just hit shift enter, and here it will be printed out as 8. So we cannot do that. We have to write the class name here to access. So auto trading bot, we have to print it here. So auto trading bot, and then what we'll do, we'll print the, and I'll remove it from here. Doesn't make sense here. So now you can see that we have 1, 2, 3, 4. Each time an object is created, the value of the counter will get incremented. So this is how we can use the static variable, and that is the difference between static and instance variable. Static belongs to the class, and instance belongs to the function, or we can say object. So to access the static variable, we have to use the class name, correct? And to access the instance variable, we have to use the self. This was it for this. And similarly, we can have static methods also. So for that also, the same process applies. We have to use the class name, and with the help of that, we can access that. So here, static attributes are created at class level. Static attributes are object independent. We can access them without creating instance of the class in which they are defined. The value stored in static attribute is shared between all instances of the class in which the static attribute is defined. Means we can use this counter value in all the methods here, right? Because it belongs to the class, not a particular. So that was it for the static variables and static methods. And in the next session, we will cover inheritance, abstraction, and polymorphism. Then we will finish the object-oriented programming. Now we will start with a very simple, very easy, but very important topic, that is aggregation and inheritance. And after that, we will complete polymorphism and abstraction, and then we'll be done with the object-oriented programming. Why I am taking so much of time in this object-oriented programming? Because this is the most important topic, correct? If you understand this properly, then you'll be able to create any kind of strategy with the help of this concept. Overall, we can say that this is the last topic of basic of Pythons. So once you learn this properly, I can assure you that you will be able to create any trading bot easily. So what we will do, once we are done with this topic, before starting the advanced Python, we will create a full-fledged trading bot. Because in comments, I saw a person that he was asking, can we create a full-fledged trading bot after completing 100 days? But what I'll say, that you can create a trading bot even after completing this OOPS concept. Means day 13. Means if you have good understanding of these basic fundamentals, you will be definitely having an edge over the others. So if you have any difficulty in these topics, please watch the video again and attempt all the MCQs and tasks, because those all questions are highly researched and curated. So you should be definitely attempting all those questions, right? So let's get started with today's topic, that is aggregation and inheritance. So let's first understand some theory behind this, and then we'll proceed with the examples, right? So what we will do now, as we have already covered encapsulation, and today we'll be covering aggregation and inheritance. So first, let's compare all these three concepts, and then we'll proceed further, right? So in encapsulation, what we can do, we can bundle data and methods that operate on the data within a single unit. So we can say, like within a class, we can bundle a data and methods. Then again, we can restrict direct access to some of the object's components. So with the help of these underscores, we can make our data and methods private, and with that, we can restrict the access, right? So what are the benefits of encapsulation? It protects data integrity. Yes, we can hide them. And again, it increases modularity and maintainability. We have understood this concept in the first session of OOPS, so you can refer that again. So when it comes to the example, class with private attributes and public methods. So in some classes, we have private attributes. Generally, we have to keep all the attributes as private only to make our data more safe, right? And with the help of this syntax, double underscore, we can make our data and methods private. So that is the basic idea behind encapsulation. Then today we have aggregation and inheritance. So let's understand these one by one. So first, in aggregation, what happens? Has a relationship where one class contains reference to another. What happens, like we have a trading bot, and inside that we have multiple strategy. So what we can say, trading bot has a relationship with trading strategy, right? Again, we can say a restaurant has a menu. Means what we can say, whenever there is a has a relationship, it is known as the aggregation. So it allows independent life cycle of a contained objects, right? Again, what are the benefits of this? So reusability of components, and it enhances modularity and flexibility. It is almost same for all the concepts. Again, Like a car has an engine and a wheel, correct? Again, a trading board class containing trading strategy object, that is also an example of aggregation. One more thing I would like to add, that in encapsulation, we can provide controlled access through methods, right? We have done that in previous session. And again, it simplifies the debugging because it will exactly show us that in which method we have the issue. So we can quickly debug that issue. And again, in aggregation, it promotes separation of concerns and it simplifies code maintenance, right? That's very obvious. Next, we have the inheritance. So this is very, very easy concept because this is not a Python or we can say object-oriented programming concept. This concept is based on real life. So let's see how. This is the mechanism where one class inherits attributes and methods from another, and it enables hierarchical classification and it promotes code reuse. For example, we have a class animal, right? Inside that, we have multiple classes. So let's say we have a class of dog. We have a class of, let's say, cat. We have a class of, let's say, cow. So means what we can say, these all classes, the class dog, class cat, and class cow is inheriting some properties from the class animal. Correct? So that is the concept of inheritance. And again, what is the benefit of inheritance? So reusability of code, it simplifies code maintenance and it facilitates the addition of new features. So when we have a inheritance structure, we can quickly add any new feature. It becomes so easy because we just need to add another class in the main class. Correct? And that is a simple comparison between these three concepts. And now let's quickly see some summary of inheritance. So in that we have few pointers, like a class can inherit from another class. Inheritance improves code reuse, correct? So let's say in a class, we have written some code and that code can be reused again and again in the subclasses, the inherited classes. So we can say inheritance improves code reuse, correct? Then this is very important. Constructor, attributes and methods get inherited to the child class. So when we have a main class and what things will be inherited, so we can say constructor, attributes and methods gets inherited. The next is the parent has no access to the child class. So what you can do right now, so just understand these concepts and take a screenshot. And then when we implement the example, that time you can come back and again see these pointers and then you will get to know what these pointers meaning, right? So the parent has no access to the child class. We'll see in the example that the parent class cannot access the data and methods of the child class. But a child class can override the attributes or methods. This is called method overriding. We will understand this also, don't worry. Then the last is super function is an inbuilt function which is used to invoke the parent class methods and constructor. So without further ado, let's dive into the example and let's see how these concepts work in the real life. Let's quickly see the example of aggregation. So what we have here, for example, we have a trading bot and inside the trading bot, we have multiple trading strategy. So what we are doing here, we are asking our trading bot that I want to execute this trading strategy at this particular price. So let's say we have a class my trading bot, correct? And then we have a constructor function. So init, and inside that, okay, let me give the space here. And inside that we have a self, and what parameters we'll be giving to our trading bots. We'll tell that this particular trading strategy means the name of trading strategy, so name, and then we will provide the strategy itself, right? So strategy, correct? Then what we can do here, self.name will be name, and then self.strategy will be the strategy. But we know that this strategy is not a simple entity. It is a complex entity because the strategy itself contains a code and we cannot just pass it like a single name. So for that, we need to create a new class. So let's say I'll go here and create a new class named, let's say, awesome strategy, correct? And this strategy also have its own constructor function. So def and init, and inside that we have self, and in strategy class, what we will provide, we'll provide threshold. What it will check? It will check that whether the current price is greater than the threshold price, then it will execute a buy trade. Otherwise, it will return a sell trade. So let's apply a conditional statement here. So if latest price is greater than the threshold, then it will return by string, else what it will return? It will return a cell string. So cell, correct? Now, here we are giving the strategy. So what we will do, we'll create an object of this class. So let's say my bot is equals to my trading bot, and inside that we are passing the name. So the name, let's say, is awesome strategy. So awesome strategy. Then for strategy, we have to pass a strategy here. So for that, we have to create another object for this class, right? This awesome strategy class. So I'll write a strategy is equals to, I'll write awesome strategy, and inside that we have to provide the threshold. So let's say I provide the threshold of 100. So if the latest price is greater than 100, it will execute a buy trade, else it will execute a sell trade. So let's hit shift enter. Then we can see here it says latest price is not defined. So for that, what we can do, we have to define a method here which will execute the trade. So what I'll do here, I'll go and define a method. Let's say define with the name execute we can do, and inside that we can provide the current price. So I'll write price, and then what it will do, it will have a variable action. So it will check. So what we can do, self dot, it will call this strategy. One more thing, what we can do here, we can keep this in another function. Let's say define evaluate for our better understanding, evaluate, and inside that we can pass self and the threshold, and the self is enough for that. And here what we can do, we can give like self dot threshold is equals to threshold, and here also we have to change it to self dot threshold, right? I think now we are good to go, and I'll just so here what it will do, it will call this function. So to call this function, it has to call the object first. So self dot strategy, then the function, the method, we can say evaluate, and it will pass the latest price. So let's say 105. Then it will return a value based on this latest price. We will just provide a variable here, and we will call this function from outside of the class. So let's say if the latest price is greater than the threshold price, it will return a buy, else the sell. So what I can do here, I can return a string, a formatted string. So f, then we can say that the name of the strategy, so self dot name, is executing a action, right? So we can call here action, and then also action, correct? And then what we will do, we will call this function execute from outside of the class. So what we will do, we'll write my bot dot execute, and now we can give the price. So let's say it is 105. So when I hit shift enter, throws an error. It says takes one positional argument but two were given. So we have to give self also here, and now it says object has no attribute strategy. My trading object, we made a spelling mistake. I will change this, and hopefully strategy, let's say this strategy is being passed here, then it will go here, and we will make it this was a mistake. Why? Now it says evaluate takes one positional argument but two were given, so we missed here also. So in evaluate we gave so here we have to give the latest price also, right? Latest price, now it is good. So it says awesome strategy is executing a buy action because we have given 105. If we give 95, then it will return a selection. So this is how the aggregation works. So you can see that this my trading bot has a relationship awesome strategy, means it can have multiple has a classes, and this is known as the aggregation. And one more thing, I wanted to show you the aggregation class diagram. So for that, what I will do, I'll draw. So now as we have already understood the aggregation, So let's start with the aggregation class diagram. So how does it work? In the example, we had two classes. So this is the first class and this one is the second class. The name of the first class was my trading bot. My trading bot. And the name of the second class was awesome strategy, correct? So while drawing the class diagram, you first have to write the class names. Then you have two sections here, first and second. So in the above section, you write attributes. Similarly here also attributes. And in the below section, you write the methods, right? So methods. Similarly here also methods, correct? So now we know that in this example, in trading bot, we had two attributes. The first was name and second was strategy, correct? Similarly, in this, we had a method with the name execute. And in awesome strategy class, we had an attribute with the name threshold, correct? So I'll just write threshold and a method with the name evaluate. Until now, it should be clear, right? Now, the most important part of this class diagram is you have to mention the negative sign or the positive sign. So if your attributes are private, you just mention the negative sign. And generally, you have to keep all your attributes, or you can say variables, private, and methods you can keep public. So you will write positive sign. So that is how the class diagram works. And when you want to show that this is an example of aggregation, you have to show has a relationship, right? Because we know that this my trading bot class has a relationship with this awesome strategy, correct? Has a relationship. So, which means we can represent this class with this symbol. So you have to write diamond, or you can say a rhombus. So whenever you see this kind of diagram, you can directly say that this is the example of aggregation class. Hopefully it should be clear. Now let's start one of the most important topic of the object-oriented programming, that is inheritance. And trust me guys, if you learn how to write code in terms of inheritance, your code will be very simple, easy and readable. Because those programmers who always writes a program in terms of inheritance, their code is so smooth, so awesome to read and understand. So the first question is, what is inheritance? So what we can say, inheritance is not the concept of programming. It is the concept taken from the real world. We can see that any child by default inherits all the property from his parents, right? By law or by societal structure, correct? Similarly, in programming also, child class inherits all the properties like data and methods from the parents class. Let's understand this with the help of an example. So let's say you are creating a trading bot. So means that trading bot consists multiple strategies, right? So what you can do, you can create separate class for every strategy. So let's say you have two strategies. So one strategy is for, let's say, SMA and EMA, simple moving average and exponential moving average. Another strategy you have, that is, let's say, Bollinger Bands. So now you will write the code for this. So in that class, what you will do, first you will write the name, right? Name of the strategy. And then let's say you write the type. Type means whether the strategy is a technical or fundamental, right? Again, then you write some methods. So in methods, you can write the calculation code. So a method to calculate. So a method to calculate first the SMA. And then you can also write another method to calculate EMA. Similarly, for the Bollinger Band strategy, you write the name of strategy in attributes. And again, you write the type, whether it is a technical or fundamental. And similarly, you write a few methods to calculate. So let's say first you calculate the lower Bollinger Band and a method to calculate the upper Bollinger Band, right? These are all methods and these are attributes, right? Now, the problem here is that by writing the code this way, you are violating one of the most fundamental principle of programming, that is dry. And what is dry? Dry stands for don't repeat yourself. And here you are repeating this code. means the name and type will be in all these strategies. Let's say you have a collection of 100 strategies. That means you are writing this code in 100 strategies, and that is not a good practice, right? So in order to resolve that, what you can do, you can take the help of inheritance. So now let's write the same code with the help of inheritance. Now what we will do, we'll write 3 classes instead of 2 classes. So again, we are creating a trading bot. So I'll write trading bot. And inside that, what we will do, we will create 3 classes. So the first class we create with the name, let's say strategy, right? And we can consider this as the parent class. And now we will create 2 another classes, and these will be the child class of this strategy class. So the first will be the same SMA EMA, and second will be the BB class. So I'll write SMA simple moving average and exponential moving average, and this will be Bollinger Bands, correct? So I'll just draw it. Drawing is not good, but I know you are getting my point, what I'm trying to say, right? So now what we will do, we have repeated this code, right? The name and type. So what we will do, we'll just write name and strategy, name and type, right? Name and type here. And then both these classes, right? This one and this one can use this name and type, right? And then the rest, the SMA and EMA calculation. So we can write it here, calculate SMA and then calculate EMA. Similarly, here we are calculating the lower Bollinger Band and upper Bollinger Band. So now we can say that we are completely following the dry principle. Don't repeat your code. And here we have not repeated our code, because only once we are writing the name and type, and then we can use this in multiple strategies. Like let's say every month we are adding another strategy, right? So this can be used in that. So another thing we can add, that inheritance helps us in scaling. We can easily scale our code without any problem. So that is how it works. And okay, now let's check what gets inherited. So for example, this was our parent class. So what gets inherited? The first thing which gets inherited, that is the constructor. So let me just move it here. Constructor. Then second is non-private attributes. I'll write it here, attributes. And third is same non-private methods. If the attributes and methods are private, we cannot inherit them. We have some workaround for that also. I'll show you that also after this. But for now, just understand that we can only inherit the constructor function, the non-private attributes and non-private methods, correct? Now the most important question, that what is the benefit of using inheritance? So just pause the video, and I hope you have understood this example very well. Just think and let me know in the comments that what is the biggest example of this inheritance. I'll just show you this diagram. Just see it and try to understand what is the biggest benefit of the inheritance. Definitely you will get the answer. And if you're able to guess correct, please share this video with your friends who really wants to see this, and like the video if you appreciate this effort, correct? So let me show you what is the biggest benefit. The biggest benefit is code reusability. We can say code reusability, correct? Because see here, if we were writing the code without inheritance, so we had to write this line of code inside every strategy. And let's say we have 1000 strategy. So 1000 multiplied by 2 is 2000. And it is just a single word, but you know that while we code, we have to write multiple lines, and sometimes there is a for loop also and some other functions. So it really consumes a lot of resources, and also it slows down our program. So when we are dealing with HFT, high frequency trading, it really harms our performance and results. And definitely whoever written their code with the help of inheritance, they gets an edge over us. And that's why this is the biggest benefit of inheritance. And similarly, let me show you the class diagram for inheritance. I'll write here inheritance class diagram, right? Okay, now let's see the inheritance class diagram. So suppose we write two classes. So the first class is for the strategy, right? So I'll just draw this, and the second class is for a particular strategy. So let's say this is SMA EMS strategy, and inside that we have written some code, right? Some attributes and some methods, and similarly some attributes and some method. So whenever you see a triangle, you can directly say that this is the child class and this is the parent class. As simple as that. In aggregation, we have the diamond or a rhombus, and in inheritance, we have a triangle. So this is the class diagram for inheritance. And now let's jump on the examples and let me show you how these works. Let's start with the example of inheritance. It's very interesting. Please pay attention. Your all concepts will be clear. I promise that. So let's say we have two classes here. One class is for the base strategy and another class is for the specific strategy, right? So let's write the code. So class my base strategy, and then we will define a constructor function. So in it, and inside that we will be having a self, of course, and then in base strategy we'll be having the name of strategy and the strategy type, correct? So now we can type self dot name is equals to name, and again self dot s type is equal to s type, correct? And then we will write the function. So define execute, and here also a self. It will print out that the execute method of the base strategy has been executed. And what else we can do here? Let's print another statement here, and here print that the constructor function of the base strategy has been initialized. Then what we can do, I'll just copy and paste this whole class. I'll paste here. So let's say when we are writing the code for EMS strategy, a long window, a short window. So what we will do, window, and here we can say the constructor function of the my EMS strategy has been initialized, and here we can add another method with the name evaluate self, and we can say method of the my EMS strategy has been executed. So what we need to do now, we need to create object for each of these class, and then with the help of that object we can access the data, right? The attributes and the methods. So what I'll do, I'll create the object class 1. So object my base strategy, and here I'll pass the name. So let's say I'll give the name, we can give my EMS strategy. Also the S type we can give that this is a technical strategy. When I hit shift enter, it says the constructor function of the base strategy has been initialized. Means as soon as we create the object, it will get executed by default and we'll get this printout, and this will get printed out. Now we can also check attributes and methods of this class. Similarly, if I create another object for the second class, so let me do that quickly. Object is equals to my EMS strategy, and inside that we need to pass the long window and short window. So 10 and 20, correct? And when I hit shift enter, the print statement of the EMS strategy class has been executed. That says the constructor function of the my EMS strategy has been initialized, which is expected. And again, now when we check that obj2 dot, we can see only the methods and attributes of this class only. But what is the exact meaning of inheritance? I should be able to use all these attributes and methods from this class. For that, what we can do a simple thing. We just need to add the name of the parent class. So my base strategy. As soon as we do that, and when we hit shift enter, and now when you type here dot, you are able to see all the methods and attributes of that, the execute and the name and as type of the parent class. See here, the 2 attributes and 1 method, right? And then one more thing we have seen in the theory, that if the attributes and methods are private, then we cannot access them with the help of inheritance. We need to use something else that we will discuss further. But for now, just understand that we can only access the public attributes and public methods. That's it. If I make it private, let's say, and now when I hit dot, I can see name, but I cannot access this. Let me again change it to public for now. So now we are able to access the data from the parent class, and we can see that with the help of this dot. And now let's do something more interesting. So what I'll do, I'll hit shift enter. It says me the constructor function of the base strategy has been initialized and the constructor function of the EMA has been initialized. Let me remove this one, the first object. We'll just keep the second, because our main goal is to access all the data from this child class, right? And one more thing to keep in mind, that only the child class can inherit from the parent class, which is true in the real life also, right? Only the child can do that. The vice versa is not applicable here. Make sure that you keep that in mind. So let's try to access the data. So what I'll do, I'll write obj2 dot, let's say we try to access the name. So when I hit enter, and now when I hit shift enter, it throws an error. It says my EMS strategy object has no attribute name. Means this is the my EMS strategy. It says it has no attribute name, but we know that we have already implemented the inheritance, and by right we should be able to access. Why we are getting this error? If you are able to guess, then make sure you like the video and share it with your friends who really need this video. Let me show you what is the main issue. So what is happening here, when we create the object of this child class, this constructor function gets initialized, it gets executed, right? So whenever we have a constructor function in both the classes, both the child and parent, the interpreter only execute the child class. So in order to execute the constructor function of the parent class also, we need to use that is known as the super keyword. What we'll do now, I'll just add super simple dot, and then I will type in it. Inside that, we need to write the name and as type, same like above. And if we do that, then also we need to make sure that we also pass these parameters in the child class constructor. So I'll just write the name and as type. So once we do that, and now when I hit shift enter, it says missing 2 required positional arguments, that is L window and S window. Yes. So when we create object of this class, now we have 4 parameters. So we need to pass 4 parameters. So here we can give the name, let's say new strategy name. We can see that the constructor function of both the classes has been executed, and also we are able to access the name. So this is how we apply the inheritance in object-oriented programming. So now let's try to access this method also. So what we will do, we'll write obj dot, and it will show us the suggestions. So execute, and we'll just hit shift enter. So let me just comment this out. And when I hit shift enter, it prints out the execute method of the base strategy has been executed. You can see that we are able to access. If you're really able to understand this, able to grasp the concept deeply, then please make sure that you are appreciating us with one function, and you know very well what is that, right? Let's quickly take the example of method overriding. So let me tell you what is it. You just pause the video and understand this example and write down your answer in the comments. So let's first understand this example. Here we have a class with the name trading strategy and another class with the name moving average strategy, right? And here we are inheriting. And now you can observe one thing, that in both the parent and child, we have one common thing, and that is the execute method. And now you tell me that while creating the object of this moving average class, so we are providing the arguments for this constructor function because we have inherited. So now you tell me, when I try to access this method which will be executed, child class or parent class? Okay, let me tell you, because as we have discussed already, that a child class can access all the public data from the parent class. So here, if we try to access this execute method, the child got more power. Execute method of the child class will be executed. So let's try this, shift enter. So now you can see that we have the output as inside trading strategy constructor, which is this one. And when we call this method and we have this output, executing a moving average strategy, means this child class execute function is being executed here, right? So that was the basic concept of method overriding. Now let's quickly understand the types of inheritance. Then what I'll do, meanwhile, add some examples in this notebook you can download from GitHub. And still, if you get any issue, please feel free to leave a comment box and we'll be happy to answer you. So let's understand the types of inheritance. Let's quickly understand the types of inheritance, and then we'll be done with the inheritance, and then we'll proceed with polymorphism and abstraction, and that will be the end of basics of Python. And after that, we'll proceed with the full-fledged algo trading bot with the help of these basics of Python. And you will see that what we can achieve with just the basics. And once we are done with the advanced, and then you'll be doing amazing things. So let's get started with the types of inheritance. So let me write types of inheritance. The first one is the single inheritance, which we have been doing previously. That is single inheritance. And what happens in this? We have a parent class. Let's say we have a parent class, and then another class is derived from the parents. That's a simple one, right? Parent class and child class. Simple. The second is multi-level inheritance. Here what happens, like we have a parent class and then a child class is derived from the parent class. And now this parent class can be derived from a grandparent class. So we can have any number of classes here. And the last class, let's say the child class, can access all the properties from parents and the grandparents, all the above classes. So that's the power of multi-level inheritance. And this kind of inheritance is used mainly in the big applications where we have a really big code, right? Then the third type of inheritance is hierarchical, right? So here, let's say we have a parent class and these parents are a little bit more romantic. So they have multiple childs, right? So you can say C1, C2, C3, C4. That's it. So this is the hierarchical inheritance. The fourth one is the multiple inheritance. Multiple. In this, what happens? We have multiple classes, right? So you can say parent 1, parent 2, and from these classes, there is a derived child class. This type of inheritance doesn't exist in Java, right? Because Java says this might cause ambiguity, which is correct. But what Java says, that a child cannot have two parents. But what Python says, that yes, the child cannot have two parents, but it can have mother and a father, right? So with that, we are able to have multiple inheritance in Python. The last but not the least is hybrid inheritance. So in this, for example, first we have a multiple. So parent 1, parent 2, and we have a child, right? Child class. Then with this, we have a hierarchical class, right? So let's say this is the base class and we have C1, then C2 and C3. Correct? And here also we can have multi-level also. Let's say D1 and D2 and D3. So this is the multiple, right? And this one is the hierarchical and this one is the multi-level. So this is the example of the hybrid inheritance. Let's quickly see some examples, and so then what you can do, you can run all those examples in your system and let me know if you have any doubt. So let's proceed with the examples. This is the example of single inheritance. Child class is inheriting from the parent class. So when we hit shift enter, you can see that we have the 10,000, which is from the parent class, and 20 from the child class. Next, we have multi-level inheritance, where we have a class with the name trading strategy. Then we have the child class, which is moving average strategy. And again, we have a grandchild from all the above classes. So here you can see that this grandchild class is accessing the self-load capital from the top class. Then it is accessing self-load short window, and then last accessing from the class itself. So when we try to hit shift enter, we'll see the results, that is 100,000, 20 and 50. Next, we have hierarchical inheritance, in which we have a parent class, which is trading strategy. And then we have two child classes, moving average strategy and momentum strategy. And both are inheriting from the parent class. Let's hit shift enter and we get the result, that self-load capital in both the classes, and that is true. The next is multiple inheritance. This is a little bit tricky. So here you can see that we have a parent class trading strategy. Then we have two child classes which are inheriting from the parent class, correct? Then in the last, we have another child class which is inheriting from the topmost class, the fundamental strategy. So here what is happening, that this hybrid strategy class is inheriting from trading strategy class, technical strategy class and the fundamental strategy class. So when we hit shift enter, we get the values 100,000 from the topmost class. Then we have RSI, technical strategy class, and then we have PE ratio, which is from the fundamental strategy class. The last but not the least, we have the hybrid inheritance. So here what is happening, we have parent class trading strategy. Then this technical strategy is inheriting from this. So it is a single inheritance, right? Then we have another fundamental strategy class. This hybrid strategy is inheriting from the trading strategy and the fundamental strategy. This is multiple inheritance. When we try to access, we get the output from all of these classes, this 100,000, the RSI and the PE ratio. So this was it for the inheritance, and we have covered extensively, comprehensively each and everything from the inheritance and from the object-oriented programming and from the basics of Python. And I think if until now you have attempted all the multiple choice questions with the mini project, then I can promise you that you will never face any fundamental issue, because if your fundamentals are strong, then your learning will be quicker and very faster when we are learning the advanced Python and all the libraries. So I highly recommend you that please go through all these videos again and again until and unless absolutely clear in all the concepts. Very, very important and very basic and very fundamental. With that being said, I'll see you in the next video. Until then, take care, bye bye, have a nice day. And if you really like this video, if you really think that this is useful for you, then please don't forget to share with your loved ones. Please don't forget to like and subscribe our channel. Until then, see you.